So today's lesson, lesson 7, page 599. We're all there, I hope. We're now bringing in like the smallest amount of context. So when we talk about slope, often you're talking about a rate. So a rate, this is coming back to like physics, a rate might be speed or like dollars per minute. Those sorts of things are rates. So at the end of the day, we're just putting units into our slope calculation. So this first example, they have distance compared to time. So our x values are time in hours. So when we calculate our slope, we're going to have distance over time, which hopefully you guys can think back to science class. When I go distance divided by time, what do we get? Speed. So our slope actually represents your speed. So let's figure out our slope. I can do 123. Remember, y is always on top, and then I have 40 and 1, which gives me 80 over 2, which when we do that division, I get 40 with units, kilometers per hour, because it was kilometers were my two y values, and hours were my denominator. So this is bringing context in. So our slope represents the speed of 40. Crazy difficult, correct? Okay, let's go to the second example. We're now looking at an oven. So the temperature increases as minutes increase, right? Like if we're preheating an oven. In theory, like this is a crazy oven because it's heating up really fast. But eventually, like likely they're heating it up to a certain point, it's going to plateau, right? Because then your oven stays at 375 so you can bake your cookies. The slope of this line, so 350 minus 50, so that's our degrees Fahrenheit, over 5 minutes compared to 0 minutes. So I get 300 divided by 5. Sorry, 300 divided by 50. 30 divided by 5 is 6, so I know that this is then 60. Do you guys do tricks like that in your mind? So I get 60 degrees Fahrenheit per minute. So it's heating up, I would say, really fast. I wrote 50 at the bottom. My apologies. That should just be fine. Go ahead, Khalil.
This might not be the most related question, might be not very specific, but is the line not the graph, not sorry, the origin, the reason why you can't just divide like the coordinates by itself?
So this case, it starts partway up because there would be like ambient room temperature. So that's why it's not at 0, 0.
But just generally, when you're calculating the slope, you can't just divide one over the other because you can't.
Well, because it's slope.
0, 0.
Correct. Yes. Yeah. I've kind of answered B and C within my first question. So it's 60 degrees Fahrenheit is what it's getting at per minute. Pretty simple questions. These questions right here, these warm-up questions would be like level 1, 2. There are an actual context that we're going to go over and like a little bit more in depth as we go through a little bit more. So turn your page. I'm going to talk in general about this question a little bit and just not follow like their setup. So in this one, we're talking about distance in kilometers compared to fuel, liters of fuel in our tank. This slope has a negative slope, right? And that makes sense. As you drive, fuel gets used up. So it should be getting less and less fuel as we're going a further and further distance. Your slope on this one, when we calculate it, should also therefore be a negative slope when we actually plug in our numbers. The order you plug in your coordinates doesn't matter, but make sure like that's one set of coordinates. But first versus second doesn't actually matter. So in this case, 50 minus 40 gives me 10. 20 minus 120 gives me a negative 100, which reduces to negative 1/10. Or if I did that division, which is kind of nicer because of the context, think of it as a decimal, is negative 0.1. So my fuel's decreasing at a rate of 0.1 liters per kilometer. Which I feel like is a lot. Go ahead, Khalil.
Is like in science you have to show units
No.
Accumulating it more than-
You can just put them in at the very end. So there's a couple ways in math, even in science as well, that you could describe this. The rate of change of our fuel tank is negative 1/10 liter per, I wrote this in wrong, negative 1/10 liter per kilometer, or you could describe it as decreasing at 1/10 a liter per kilometer. So depending where you put that, if you put the word decreasing in, you don't then use the word negative. And that's because that's like, they contradict each other then, right? So you just have to be a little bit careful. From here, we can use this information to write the equation of this line. They said, and I feel like this is a typo, you want the equation in this form, but they put a capital D. I think it should be a lowercase d because they have a lowercase d here. But regardless, this is just a different way of saying they want it in slope-intercept form. Mx plus b. They're using n and d because they set number of liters compared to distance on the original graph. I don't care. If you use x and y, use x and y. If you want to use the graph provided, use the graph provided. Don't like use x and then use, in this case, n. Like be consistent with either using x and y or whatever the provided variables were. But to me, that's flexible. Go ahead, Khalil.
So if it was, if the amount of fuel, for example, was to increase, could we say it could decrease by negative amount?
Yeah, but that's weird, and don't talk like that.
And if it was decreasing, could we say it was increasing by negative amount?
Yes, but also don't talk like that because that's not proper English.
Proper math.
No, it's yes, but it's also not this in the simplest form, and math is always in the simplest form and the clearest form, and that's not very clear.
So
So
it's marked down.
You 100% would be. Plus, you'd annoy your teacher, which is never a good thing. Okay, so slope-intercept form. Do we know our intercept here? No. We could probably approximate it. Do we approximate things like that? No. So how do we solve this one? We have to use slope point form. So we know, though, a point, and we know our slope, so we can successfully do that. So I'm going to have y minus 50, let's say. Could I pick the other point if I wanted? Yes. And then 50 and 20, right? Yes. Because I'm going to slope intercept form, I don't have to get rid of the fraction, right? Only general has no fractions allowed. If you wanted to get rid of it, go for it. Just like if you don't like fractions, that's kind of a personal preference. Regardless, I'm going to distribute my negative 1/10 through. So I get y minus 50 equals negative 1/10 x. A negative times a negative gives us a positive. I'm going to show all my work right now, but you could go directly to the next step. When I multiply it 1/10 by 20, what do I get? 2, or 20 over 10, which reduces to 2. I'm showing that step because this is your notes, but by all means, you could skip that step and just go directly to y minus 50 equals negative 1/10 x plus 2. I need to isolate y, so I'm going to add 50 to both sides. So that is our equation for this graph. Questions that are like our application questions, we really like, and I say we as in like the Alberta curriculum, it seems like, and diploma exams, not me personally, really like commission questions. Do you guys know what commission is? Good. So it's like incentive for workers to sell more. So often like in mattress stores or appliance stores or car salesmen and even realtors for that matter. Realtors are a little bit more complicated, but they receive a commission. So the amounts you sell in dollars, usually, you earn a percentage of, plus a base salary, right? So they're like, you're showing up for work, we're going to pay you something. It's not great, but it's not your fault if no one comes in today, so we're going to give you something. And then the more you sell, the more percent income you earn based on those sales. Often even like in clothing stores, if you go to the till and they're like, did anyone help you today? And you can be like, oh, Tiffany did. Then Tiffany gets a percent income off of whatever you sold then. So commission questions come up lots in math. It's a weird thing. So here's a commission question that we're going to go over. So these are the questions, I would say these are like a level 5 type question. So Tyrone is paid a base salary per week plus commission for selling electrical appliances like ovens and fridges. Last week, his sales totaled $3,500 and he earned $620. So that includes his base salary. This week, he earned $680 for sales of $4,250. Questions like this, often we provide a little sketch of a graph for you. Pay close attention to what's already labeled on there for you. So in this case, they've labeled our X to be our sales, and then our Y values are earnings. So our sales, I'm going to very arbitrarily, but draw a sketch. So if I have my first point here, that's going to be the 620. Sales is, just kidding, that's my Y value. Sales is 3,500. And then his earnings is 620. The second data point, they sold more, so it's further to the right at 4,250 and earned 680. You will always have a linear relationship. So we know to sketch it in a straight line. Did I actually know the slope of that line? No. Could I figure it out? Yes. So calculate the slope of joining these 2 points. So make sure, again, our earnings are our Y's. So I'm going to have my 680 minus the 620 over 4,250 minus 3,500. Jacob, we should be writing this down and not just playing with our water bottle. When I subtract that out, first off, your test, I said you won't get a calculator. I'm going to give you nice, pretty numbers to subtract. These ones aren't that hard, but ours would probably be even prettier than this because you guys struggle with basic subtraction sometimes, and I don't want you to really struggle because you can't subtract. When you do that division, I put an extra 0, 750. When you do that division, we get 0.12. That 0.12, just kidding. I'm looking at the wrong question. We get 0.08. My apologies. Make sure you write down that actual answer. When you do that division, you get 0.08. So that means they get 8% commission. Remember, whenever we work with percentages, you work within decimal form. So that means he's earning 8 cents per dollar that he sells. Part E says calculate his base salary. So you have to really understand commission in order to do this. So like I said earlier, his earnings are equal to the percent commission, which in this case is our 8%, times their sales plus his base salary. That's the case for every commission situation that we're going to come across in math. In real life, it's often more complicated. But for our purposes, that's what it's always going to be. So from here, we know some of this information that we could fill in. So we know, for example, he earned $620. His percent commission is 0.08. We knew in that case, when he earned $620, that he sold $3,500 worth of stuff, plus that base salary. Could I isolate and solve for B now? Yes. 0.08 times 3,500 gives us 280. Then I would subtract 280 from both sides. So his base salary, no matter what, he's going to earn $340 per week. So assuming he's working 5 days a week, 8 hours a day, is that very much money? No. So usually I would say commission's probably a little bit higher. This isn't that great of a job. That 340 would be our y-intercept. I think there's another, yeah. So this question kind of continues on the next page. So in general terms then, like if I take away the point, his earnings then is equal to 0.08 times his sales plus $340 a week. So he could figure out, if he knows that he needs to earn $1,000 a week to pay his expenses, he could figure out how much he has to sell each week in order to like budget correctly, right? Like you could figure that out based on this kind of stuff. 2 weeks ago, Tyrone earned $486. Could we figure out his sales? Yes. Do I need to go through that? I'll write it out, but I'm not going to go through it. I feel like you guys can handle this. But it would be 846 is our final answer. 0.08 S plus 340. Isolate and solve for S, which I really feel like you guys can handle. The harder of these types of questions is what this last example is. When we're talking about average speed, so similar to the very first warm-up question, getting a little bit more complicated. So let's look at this specific example. So John's in a race. After 3 hours, he's traveled 270 kilometers. After 6 hours, he traveled 360 kilometers. Which one of those hours, would that be our X or our Y on our graph? X. Good. Time is always X. So our hours is here, and then our distance is up here, which means our slope is then our speed. Distance over hours. I'm not going to make you guys actually count this out, but essentially I'm going to have a data point here. I'm saying like arbitrarily at 3 hours and 270. We're going to have another data point here at 6 hours and 630. Straight line. So B is calculate that slope. Make sure Y is your numerator. So I have 630 minus 270 over 6 minus 3, which gives us 360 over 3. 36 divided by 3 is just 12, so then I can toss on a 0. So he's going only 120 kilometers per hour. Is that fast or slow for a race? I would say that's slow. Like the speed limit on the highway is 110. Most people are going 120 already on like highway speeds. So if he's racing, I would have thought they'd be going a heck of a lot faster. I know, maybe they're racing through like city streets or something so that it seems faster. The slope, so I did C in question B by putting in our speed. Our slope in this example is actually changing. So in theory, they're going to start at 0 hours and 0 distance from the beginning. And this then, the slope changes. So let's find out the speed he was going initially at the beginning of this race. So basically, I'm just figuring out our speed again. I can use 0, 0 as my set of points. I'm choosing to point it second just because then I get to deal with positives. Could I put it first? Totally. So then I have 270 over 3, which gives us 90 kilometers per hour. So he's going a little bit slower, and then he speeds up. You can also tell, like, I knew that this was coming. when I just randomly drew my points, but your slope won't be as steep then. Go ahead, Khalil. You didn't until you calculated that it changed. I knew that it changed because I've done this question before. You don't know that if you actually took the time to like plot out the hours and points and like put ticks on your graph, you would see that it couldn't have been a continuous straight line. So if you graphed it properly, not just approximately, you would have probably been like, oh, something looks off here. That would have been your other. Yeah, exactly. I just don't think it's worth your time to actually draw out all the ticks. You guys can graph here in grade 10. Okay, that's it for my formal lesson. So you only have to do numbers 2, 4, and 5. I do want to say something briefly about number 2, though. So if you could turn to number 2 in the practice questions. Let's read this question first. You don't have to finish them today. I know. So a number 2, Absolute Value Car Company, was formed in 2002. By January of 2004, the company had sold 520,000 computers. By July, the company had sold 610,000 computers. Calculate your rate of change. So a good strategy, here we're basically saying find your slope. Draw a little graph. If you were to graph this information, what would go on your x-axis? The months. So what numbers then could go with months? Because we're not doing a bar graph. Good. So it's be like January is your first month. July is your 7th month. And then your number of computers is your Y. So this first like tidbit of information that it was formed in 2002, do we care? No. Do we even care that it was 2 years later this data came out? No, because we're looking within the same year. This question could be a lot harder if it was like your first date was, let's say, November 2003, right? Because then you have to think slightly more about the number of months. I mean, it's not a ton more difficult, but it just, you have to be careful with that. So I really suggest it. Think about how would I graph this to determine your X and Y. So some of the questions will tell you what your X and Y are, some won't. Think about the graphing of them. But all you have to do is 2, 4, and 5.